in that when we multiply a times the components of those, or maybe these vectors which are in brackets, it's going to give us that specific product. So in this case, of course, we're going to look at the combination of the unit vectors that we have talked about, and some of the behavior we're going to see if we maybe to do the cross product of a vector like AB. Now remember, in a three-dimensional space, we give the components of vector A as AXI plus AYI plus AZK. This is J. So these are the components of vector A. You can just use that one or the hearts. So for B also we can be able to describe its components as xi plus by j plus b z k. So those are the two respective components of those specific vectors. Now the dot product of AB therefore is going to be represented by having the component of A and then we do a cross with the components of B. I'm going to, okay, just there's something I want to illustrate. I'm just going to put something over there. So we have a component of this one, and then B, Z, K. So we are having a dot product of those specific components. Therefore, this is going to be the sum of the A components plus the sum of the B components for those respective vectors. Now that we have talked about the concept of a unity vector whereby the I equals J equals K, which is going to give us 1. Those specific components are going to give us the product of 1. So therefore, for the first one, we're going to multiply the first component with the first from the second one for B. So the product for this is going to be X. Now that the I component has disappeared, plus AY BY plus AZ BZ. So that is going to give us the dot product of those two specific vectors.